Hello, and welcome to my Pre-Algebra review series. This video covers Chapter 10, Section 8, titled Make a Model. By the end of this video, you will have reviewed recent lessons regarding the creation of a model to help you visualize the problem and then finding the solution. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it will certainly help this channel to be seen by more people. More students in particular. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's do this one. Objective 1. Make a model. Math strategies in action. Architects build and use models when they plan. When they design buildings, they experiment with models. When they design packaging, they first create a prototype models. So example 1A, real-world problem solving. Read and understand. This is our typical three-step solution that we've seen many times throughout this review series here. Read and understand. Step 1. Packaging. A box company makes boxes to hold popcorn. Each box is made by cutting the square corners out of a rectangular piece of cardboard. The rectangle is 87.5 inches by 11 inches. What are the dimensions of the box? What are the dimensions of the box that holds the most popcorn if the square corners have side lengths of 1 inch, 2 inches, 3 inches, and 4 inches? Okay, so the question here is, what we need to do is first read and understand the problem. So what they want to know is, what is the goal of the problem? And the goal of the problem is they want to find a box that will hold the most popcorn. That's the goal. Most popcorn. Okay, that's the goal. That is, what information do you have to help build a model? Well, we know the size of the piece of cardboard. They're giving us 78.5 inches by 11 inches. We know that. And they tell us the size of the corners, that they want us to try 4 different boxes, one with corners 1 inch, 2 inches, 3 inches, and 4 inches. So that's what they're giving us. Size of cardboard and corner sizes. And that's 1, 2, 3, and 4 inches each. So that's the start. Now that's what we know what they're looking for and what they've given us. Reading and understanding the problem. Okay, example 1B, we're continuing on with example 1 of this real-world problem. Plan and solve. This is part 2. To find the size that will hold the greatest amount of popcorn, you must first find the dimensions that will give you the greatest volume. Makes sense? Build 4 boxes using sheets of 8.5 by 11 paper. Test 4 whole number, like 1, 2, 3, 4. Test 4 whole number lengths of cuts. Okay, and what are they going to be? We know they're going to be, I think we already saw it, right? They're going to be 1, 2, 3, and 4. But let's go. We're going to move on to the next slide. Okay, so plan and solve. Continued. Still example 1B. So what are the dimensions of the box corners, of the box with corners 1 inch by 1 inch? So the dimensions are, and then it says, what is the volume of the box? Well, the dimensions, if you take 1 inch out of each side out of the 11, it's 9, right? And if you take 1 inch out of each side out of the 8.5, it's going to be 6.5. So I'm going to say that the answer, and that's going to be 6.5 and 9. Okay? And it's going to be 1 inch tall, right? By 1 inch. It's going to be an inch tall because you're making 1 inch corners on it. So what is the volume? 6.5 times 9 times 1. Well, if you multiply that up, you're going to get 58.5 inches. Inches what? Inches cubed. Okay. So when you cut a 2-inch by 2-inch square from each corner, what effect does that have on the length, the width, and the height of the box? Well, for the height of the box, it's now going to be 2 inches tall, and the width is going to be 4 inches narrower than it started, which it was 8, now it's going to be 4. And the length is going to be 4 inches shorter than it started. At 11, it's going to be 7. So everything's going to be smaller for sure. We're going to have, what did I say? We're going to have a length of 7 inches, and we're going to have a width of 8.5 minus 4, 4.5 inches, and a depth of 2 inches. Okay? So the height increases by 2 inches from flat, right? Okay, measure to find the dimensions of each of your boxes. So we're gonna find the volume of each box. Which box has the greatest volume? Okay. Well, if you do this, you're gonna find out that you've got take the volumes of all of them. We're gonna end up finding that we have a box width of 2 inches by 2 inch corners has the greatest volume. Okay, 2 inches by 2 inches is going to be with the corners will be the greatest. And is it so? Then also, so that's because we did a box with 1 inch corners, 2 inch corners, 3 inch corners, and 4 inch corners. We went through all the boxes and did it. Okay. I'm not showing the work, but it's the same work. We just do what we said. Is it possible to create a box with 5 by 5 inch corners? And the answer to that is no. And the reason why is because if you take 5 by 5, you're taking 10 inches. And the thing is only 8.5 inches wide, so you can't get 10 inches out of an 8.5 inch wide paper. So you don't have not enough material. Not enough material. Okay, example 1C, the real world problem. Look back and check. Now that we've kind of thought about it and came up with our answers, we can look back and check. And a good way to look back and check, or even to solve the problem to begin with, is list the size of the cuts in a table and then find the length, width, and height of the box and find each volume. So we have a table here with the size of the cuts are 1, 2, 3, and 4, right here down the side. 1, 2, 3, 1, 2, 3, and 4. That's our inch cuts on our making the corners. And the length with a 1 inch cut is you have to subtract 2 because it's 1 inch from each side of the length and each side of the width. So we started with 11 inch length, 8.5 by 11 paper. So now we're going to cut 2 inches from that. We're going to remove 9, remove 2, it's going to be 7 inches. And 6.5 minus 2 is going to be 4.5 inches. And then the height is going to be 2 inches. And the volume is going to be, if we multiply this out, we get 4.5 times 1 times 7, right? This thing multiplies out. It's going to be 63 inches cubed. Okay, so if we do 2 more inches, we're going to have 5 inches over here. And then we're going to have 2.5 inches. And then we're going to have 3 inches. And then the area here is going to be 37, if you multiply it out, 37.5 inches cubed. And now we'll go to the last one, 4. If we do the 4 inch corners, we're going to be 11 minus 8 is going to be 3 inches. And 8.5 minus 8 is going to be 1/2, 0.5 inches. That's the width of our box. The height of the box is going to be 4 inches tall. And the volume of our box is going to be 6 inches cubed when you multiply that out. Okay, because look at 1/2 times 4 is 2, 2 times 3 is 6. Okay, so now we have the volumes. Right now we can see that the 2-inch corners has the largest volume. And it looks like the decimal point is missing here. I didn't miss it, I don't think, but it just didn't show up. Decimal point, 37 and a half. Okay? So now we're going to go on to, you get to try one. Okay, example 1, check your understanding. Make a model. Or in our case, we're going to use the table. Find a table. Use a table to find the volume of a box folded from an 8.5 by 11 sheet of paper if the square corners are now 1.5 inches, 2.5 inches, and 3.5 inches. So, and then at the end it says, did you find the dimensions of one of the box that holds a greater volume than what you did in question 7? And why? Well, that's going to be an interesting. Oh, no, it's which dimensions are they? Okay, sorry. So go ahead and try this on your own. When you come back, we will try it together. Okay, now that you're back, let's look at it. So we got the table. We have 3 rows this time. We have 1.5, 2.5, and 1.5, 2.5, and 3.5 inch corners. And we have the typical length, width, and height, and volume. So the length started at 11. We're going to take 1.5 inch corners, which means 3 inches. So 11 minus 3 is 8. So we're going to start with an 8 inch length. The width is 8.5 minus 3, right, is 5.5, 5.5 inches. And the height is going to be 1.5 inches. And the volume is going to be, if we multiply this up, we're going to get 66 inches cubed. Okay? Now, if we do the 2.5, we're going to get, that's 5 inches. So the length is 11 minus 5 is 6 inches. The width, 8.5 minus 5 inches is 3.5 inches. And the height is now going to be 2.5 inches. And the volume is going to be 52.5 inches cubed. So you see they're going down. Already we see that the first box with the 1.5 inch cuts has a greater volume than the 2.5 inch cuts. And we don't even have to do the third one, but we will. That's 7 inches. So 11 minus 7 is 4 inches. And the width is 8.5 minus what? Minus 7? Is that 7 inches? 8.5 minus 7 is going to give us what? 1.5 inches? Okay. And the height now is 3.5 inches. And the volume is 21 inches cubed. Okay, so now we know that the 1.5 inches is the greatest volume. Then it says, did you find the dimensions of the box that holds the greatest volume, a greater volume than you did in question 7? Well, in question 7, the number was 63 inches, 63 cubic inches. Well, we find here, and that was for number 2, for the 2-inch box. Well, here, the 1.5 inch box, we find is 66, right here, 66 inches cubed. So yes, the answer is yes, we did. And what are the dimensions? Oh, which dimensions are they? They're the ones that were the 5.5, or 5.5 times, what was it? It was 1.5, right? No, 5.5. No, I'm doing that wrong. I'm adding up the numbers wrong in my head here. It's, go back to the ink. It's 8, the box that's 8 inches by 5.5 inches by 1.5 inches. That is the box dimensions. Okay? That gave us the greatest volume. And I did notice here that I wrote this as a decimal and this is a fraction, but you understand.